Section 3.3 is on rules of differentiation. It's pretty clear that we can take the derivative of any function, but that means we have to evaluate the limit each time, which can get really cumbersome, especially as the functions get more and more complicated. And so there are some shortcut rules that we can use. So we're going to start introducing those shortcut rules. Okay. So from before, we know that if the function is horizontal or is a constant, then its slope is going to be 0. So that's our first differentiation rule. If our function is a constant, the slope or the derivative is 0. So the notation for this is d dx, the derivative of a constant, is equal to 0. It's our first differentiation rule. Okay. Moreover, we know that the slope of any linear function, line, it's pretty obvious, it's m, right? So the slope is m for a line. So that means that if your equation f of x is any line mx plus b, that means that its derivative, I don't have more purple, I got blue and pink. Sorry, I got my daughter here today. So that means that its slope is that coefficient. That slope is m. Okay? Now, whatever we call it, it doesn't have to be called m, but it's that coefficient of x. It's the slope of the linear function, so it's the derivative. It is the derivative. If your slope, if your line function is a line, its derivative, its slope, will be the slope, because there's only one slope. It will be constant. No. This is actually very helpful since it starts up a pretty interesting and useful pattern. All right, if my function is x, its derivative, f prime of x, will be 1. 1 is the coefficient right there. Okay. Now, this pattern, and we can prove this using the limit definition, comes from the power on the function. So the pattern would be, if my function had x to the 1, its derivative will be 1 times x to the 0, which is 1. So I pull the power down and then reduce the power by 1. Okay. We can prove this using the limit definition. There very well could be a test question proving the limit definition with one of these 2 or 3 functions here. And then the rest of them we're going to generalize from the limit definition and use this new rule. Okay. So with this rule, the derivative f prime for x squared becomes 2 times x to the 1, or just 2x, reducing the power by 1 and bringing that coefficient down. So for x cubed, the derivative is 3 times x to the second. And again, just illustrating that power comes down and you take 1 off. So the derivative for x to the 4th is 4x to the 3rd, and the derivative in general for x to the n will be n times x to the n minus 1. That's going to be our pattern in general for finding the derivative of a power function.